Hello students, today we will study the question number 8 of exercise 7.1. This is the topic of standard 9, chapter number 7, triangles. So what is the question? The question is in right angle triangle ABC. So first of all, we have given is that this triangle ABC is a right angle triangle and right angled at C. So this is the 90 degree of the angle. So we can write down this thing in the given section that angle ACB is equals to 90 degree. Okay, M is the midpoint of hypotenuse AB. This point M is the midpoint of hypotenuse. That means these two portions are equal. That we can write down also in the given section that BM is equals to AM. Okay, now C is joined to M. When we join this C and M and produce to point D by joining C to M and again produce to it up to point D, such that DM is equals to CM. See, this portion is also become equal to this portion. So here also we have given that DM and CM are equal to one another. So we have to show that first thing we have to prove here is that triangle AMC is congruent to triangle BMD. This is the first thing that we have to prove here, right? So where is the triangle AMC? AMC is this triangle, this portion, and BMD is this portion, this triangle. So see, two conditions already we have given is that BM, this if we talk about this triangle, we can write down that AM side is equals to BM side. In the same way, we have given that CM is equals to BM. So these two conditions we have already given. Now think about the third condition. Yes, it is very easy that these two triangles, these two angles are vertically opposite angles because the two lines are intersecting here. So this angle we can write down that as angle AMC, and that will become equal to angle AMC, that will become equal to BMD. The reason is vertically opposite angles. So three conditions are there. Now we can write down that yes, the triangle AMC is congruent to triangle BMD. By which rule? See, two sides and included angle. That means side angle side rule. By side angle side rule, we can write down that these two triangles are congruent. Now, second thing we have to write down here is that we have to prove the second thing is that angle DBC is right angle triangle. Angle DBC is a right angle. Now see how we can prove that DBC is a right angle. DBC means this angle. Yes, one of the angle we have given is that this ACB is right angle. So you are thinking that yes, AC is parallel to BD. If we take CD as a transversal, then the addition of these two angles will become 180 degree. This is 90 degree. So yes, obviously this angle will also be 90 degree. Yes, you are thinking the same. But here we have not given that AC and BD are parallel. We can apply this thing only when we have given that CA and BD are parallel. But this thing we do not have given. So what we can do? We can prove that AC and DB are parallel. If we can prove this, we can write down that the addition of these two angles will become 180 degree. So how we can prove this? See, here we have proved that AMC and BMD, two triangles congruent. Then their corresponding parts will become also equal. Yes. So now consider this angle and this angle. So the angle ACM of this triangle, angle ACM will become equal to BDM, angle BDM by CPCT, right? By CPCT we can write down this thing. So this angle we have to now consider here. Here we have angle ACM is equals to angle BDM. This condition we are taking from 1. So this we have already proved in 1. So see, here two lines are there. DB and AC are the two lines. DB and AC are two lines, and DC is transversal. DC is transversal, and these two angles are making a pair of alternate interior angles and they are equal. So according to the by theorem number 6.3, what we can say by theorem 6.3, if there is a two lines, one transversal is intersecting, and if the pair of alternate interior angle will become equal, then by theorem 6.3 we can say that the DB and AC are parallel. DB will become parallel to AC, right? So what we required here is, we required to prove that DB and AC are parallel, that we have proved here. Now we can write down that angle ACB plus angle DBC, the total will become equal to 180 degree. What is the reason? Reason is interior angles, right? The addition of the two co-interior angle will become 180 degree. Now out of that, ACB we already have, that is 90 degree. Put down here 90 plus angle DBC is equals to 180 degree. So when we take 90 to the right hand side, we can write down angle DBC is equals to 90 degree. And what is the meaning of this? That is, angle DBC is what? DBC is a right angle. So in this way we can prove this thing. Now see, the third thing that we have to prove here is triangle DBC is congruent to triangle ACB. Right? Now these two triangles, consider this two triangle. DBC, this triangle DB and C, and ACB means ACB, this triangle. See, BC side is common, right? So we can write down that BC is equals to CB. This is common in both the triangles. Now one more thing, that is angle DBC. We have currently proved that angle DBC is equals to angle ACB. Both are of 90 degree, right? This angle we have currently proved, this ACB we already have given. So two conditions currently we have. Think about the third condition. See, in both this triangle, AC side and DB sides are there, but AC and BD are not given equal. See here, again, we have proved here that AMC and BMD are equal. So we can take the AC side and BD side. By CPCT we can prove that? Yes. So AC side will become equal to BD side. This we can write down according to CPCT, corresponding parts of congruent triangle. So this thing we are using here. We can write down that BD is equal to CA or AC. This we have already proved in 1, right? This condition we are taking directly from the here. So three conditions we got here. So we can write down that triangle DBC is congruent to triangle ACB. By which criteria? Think about, this is the side, and this is the angle. So by side angle side rule. Okay, now let us see the fourth condition that we have to prove is CM is equals to 1/2 of AB. Right? As we have proved here that the two triangles are congruent, we can write down this that DC side is equal to AB side, right? DC side is equals to AB side by CPCD. This condition we have to use here, that BC is equals to AB. This we have already proved in third, right? This condition we are using here. Now see DC. We have given that DM and CM are equal. So instead of DC, we can write down DM plus CM. Instead of DC, we can write down DM plus CM, and right hand side keep as it is. Now as DM and CM are equal, instead of this DM, we can write down the CM. So CM plus CM will become equal to AB. CM is 2 times, we can write down 2 CM is equals to AB. When we take this 2 to the right hand side, we get the CM is equals to 1/2 of AB. And this is the fourth required condition. See, so in this way, this is a lengthy sum, but it is at the same time very important sum. Okay, so think about this sum, how we can solve this type of sums. Okay, so this is all about this lecture. Thank you.